Hello there. You're listening to Manufacturing Tomorrow, brought to you by the Ohio Manufacturing Institute at The Ohio State University, where we discuss the latest innovations, challenges, and advancements shaping the world of manufacturing. I'm your host, Katherine Kelly. Today, we are excited to speak with Milind Karnik, CEO of Elementary, a manufacturer of AI vision inspection platforms and software that currently inspect over 1 billion parts annually in 6 countries for Fortune 500 companies. He brings more than 30 years of experience turning cutting-edge technology into high-volume products. He has led organizations of over 1,000 people and delivered nearly $1 billion in revenue across areas like AI and cybersecurity, semiconductor and silicon development, process engineering, and storage systems and software. Under Milind's leadership, Elementary developed VisionLink, the first machine vision system capable of learning quality standards directly from observing the production line, enabling it to detect defects within minutes and eliminating weeks of traditional setup time. Before joining Elementary, Milind served as a senior vice president of engineering at Cylance, the AI-driven cybersecurity company that was later acquired by BlackBerry. Before that, he founded Argyle Data Corporation and led the company as CEO. Earlier in his career, he led engineering and leadership roles at Dell, LSI, QLogic, and Intel. Milind, welcome to Manufacturing Tomorrow.
Good morning, Catherine. Thank you for the opportunity here to talk to you.
Milind, to start us off, what is Elementary and what problems are you trying to solve?
Yeah, absolutely. Elementary is a mid-stage privately held company. We are venture funded. And fundamentally, what we see is that the world of manufacturing is rapidly changing. Uh, Labor is getting difficult in terms of expertise to hire. And typically, the product sort of portfolio that most companies are making is really uh, branching out into what manufacturers typically call very high SKU counts. So maintaining quality on their product lines becomes more and more difficult. The only way to address this is with machine vision and using vision to then have intelligent inspection systems. Now, critically, vision-based inspection is nothing new, but vision-based systems that can adapt to the factory conditions, to the lines, and fundamentally can become the digital specification and hold all the information in them that a human would in terms of the quality of the product. That is absolutely new. That's what Elementary does. It brings machine vision to really a new plateau here, where the vision system can learn just like a human being does. Once learned, it can adapt, but at the same time, it never gets tired, never takes days off, and it becomes the digital standard for the quality of the products being made.
Let's get into a little bit more detail for listeners who may not be deep in this space. What does a vision inspection system actually do on a factory floor, and where have traditional approaches fallen short?
Yeah, so vision inspection systems typically are camera-based, obviously, since they're vision. So their cameras are set up to very specifically look at a product being manufactured. And very simply put, those images that the camera takes are ideally in real time looking for problems in the product, looking for defects, looking for issues within the product. So that's fundamentally what it does. Uh, what Elementary brings to the table is at the core, it's the same. But at the same time, those defects that are being manufactured can vary. Uh, Machines that manufacture product can, over time, get worn out, can go out of spec, and defects can get introduced. The complexity of the defects what the defects look like can start to vary as the manufacturing processes sort of change their tolerances. So you can get a wide range of issues. Think of a can being made and a scratch on a can or a dent, and that size and shape of that dent can start to vary. Traditional vision systems are really tuned to be pattern matching. They will look at a particular pattern and, and they will identify that. What they can't do typically is basically judge like a human being would, say that here's a problem, and well, the problem is varying. I can still judge it, but I can kind of say, I still think it's a problem. Maybe it's like I'm 90% sure. Now I'm 85% sure, 80% sure. Uh, that's essentially what a human does in terms of judging, but traditional systems can't do that. AI-based systems are trained and behave like humans, so they are able to adapt to the changes in production lines, changes in problems, and can adapt and basically provide judgments.
How should we think about AI vision inspection within the broader Industry 4.0 landscape? I mean, what does it unlock or enable alongside other technologies such as the Internet of Things or digital twins or other new technologies?
Yeah, firstly, I think the the world of manufacturing is almost going to be unable to move forward without AI-based systems. Um, the adaptability is key. The other part of the critical need of AI-based systems is the fact that consumers demand greater and greater sort of variability in the products. I mean, if I take the simple example of shampoo. 20 years ago, 25 years ago, if you went to a store to buy shampoo, you bought a particular brand and you see, you know, that brand and one kind of shampoo. Today, when you go to the store, you see that brand, but you see a variety of different uh, potential possibilities of that brand, whether it's for dry scalp and oily hair, and you'll see 20 different varieties. In the world of manufacturing, we call them SKUs or SKUs, and typically there is a massive proliferation of SKUs. Some of our customers that make products have 1,000 SKUs of a particular product a year. That amounts to about 3 to 4 SKUs running on a product line a day. And you need systems that can inspect, that can adapt to those kinds of conditions, moving rapidly from one to another. That is where Industry 4.0 is going, not just the need for hands-off, no human touch, but the high degree of adaptability to a varying product line that is being manufactured. And only AI systems can come in to be rapidly adapting to such things. A factory operator, a business cannot go back to a vendor and say, oh, my SKUs are changing. Please send your experts in to go and change the system. Those systems have to be able to adapt and change. And the second part is all that data needs to be collected. Legacy systems were integrated cameras and fundamentally islands onto themselves that did the inspections. Now we live in a connected world. All the systems need to be connected. Their data needs to be gathered. Analytics based on that data needs to be there so that factories can use those analytics to feed that data forward and see how to improve their manufacturing systems.
So as an aside, this would work on a machine that's been retrofitted so that they can collect that data.
Absolutely. And that's key to what Elementary has brought to the table with VisionLink is that for completely greenfield installations where new factories are being built, where new inspection points are necessary, we supply fundamentally our software, but we provide the physical hardware platform also that is completely new. But for existing systems where uh, inspection already is in place, but that is legacy, Elementary with VisionLink can attach to almost any existing system and basically bring that into the digital industry 4.0 age with putting elementary software behind traditional vision systems that are islands, bring the AI capability to those, bring the cloud connected capabilities, bring the entire ability to upgrade those. Our key point that we strive to make is that none of these systems, and old investments should be thrown away. VisionLink allows those to be modernized.
So let's talk a little bit more about VisionLink. One thing that stood out to me is that the ability to learn quality standards in seconds. How does that fundamentally change deployment timelines and help companies avoid getting, a lot of companies will get into a pilot mode to go down a certain path, and then they have to, back up and start all over again. So, how does that help that?
Yeah, that's right. So a part of VisionLink is also another capability that we call Vision Stream. And Vision Stream is at the heart of the adaptability and the rapid deployment capabilities. Legacy systems typically would take weeks to fine tune, write rules, to understand the patterns of defects, input all those, and they would take weeks to basically what's called in this world commission. And that says that once they're physically set up, how long before they actually become useful, before all the information that they need to actually start valid inspections is input to those systems. They would take weeks. Along came AI systems. And with AI systems, they can be provided data, but then a human has to label that data. Once the data is captured, a human has to sit with that system and basically say, here's an image of a good part, here's the defect in the good part, a bad part, here's an image of a bad part, and here's the defect. So they would have to distinguish between good and bad parts, identify where the defects are, typically provide hundreds of items, and then ask that system, go build a model, AI model, let me see that model, test that model out, make with some level of test set, and then when the human is satisfied that the model is working correctly, then they would say, well, now let's deploy that model and allow it to start inspecting. That entire process of data collection, data labeling, creating the model would take days, and the best of systems shorten that down to maybe 1 day, possibly 4 or 5 hours. But when you have a company like some of our larger customers that make products and SKUs by the thousands that last maybe for 4 hours, you can't afford a day of data collection and model building when your SKU is going to last for 4 hours. You can't even afford an hour of that work because 1 out of 4 hours and you've lost 25% of your material is gone in the production line. What Vision Stream does is it allows our customers to set up the cameras, to look at a production line, and you say, run the line. The system and the software instantly is capturing data, learns the characteristics of the line, It auto labels the data, it finds the problems, it creates the models, it tests the models, it deploys the models, and it does this typically in about 120 seconds to about 5 minutes at most. That is a settable parameter based on the variability of the line. So in anywhere from 2 minutes to 5 minutes, the system completely without any human intervention learns the characteristics of the products being made and immediately goes from data collection to labeling to model creation to deployment to inferring what the issues are and provides that information to the customer without any touch. And what we are seeing, we have actually deployed Vision Stream to our customers across the world. And we're seeing that Vision Stream is typically better than most of the experts who are using our system in the slightly older fashioned way, taking 1 to 2 hours to label. They've been doing this for maybe 1 or 2 years. They've become experts with our system, and Vision Stream in 5 minutes beats even the people who are using our system. So it's really a game-changing capability. Customers don't have to bring down their lines. Customers can have rapidly changing SKUs, and the adaptability and accuracy is fantastic.
Are you able to share a story where a manufacturer saw a meaningful improvement after adopting the platforms?
Yeah, we have a global manufacturer that has they're headquartered in the UK, but their products are sold all over the world. We have deployed capability for them in the US, in the Middle East, in Philippines, in Indonesia, and they use vision streams for consumer products that they make. And it was really a challenge, especially remotely supporting the company in Indonesia or the Philippines, training their users of how to build models, expecting them to do it right. Sometimes they would not. It takes all this sort of out of the picture. You no longer have to train the customers on how to accurately label data. You no longer have to depend on the people to basically say, did they make a mistake? Did they accidentally label a good item bad or a bad item good and therefore corrupt the model? When we released Vision Stream, they were able to set up the solution, and essentially all they say is go. And within 5 minutes, they get a model. The model has been more accurate. They get results, and the result accuracy is in 98, 99% level of accuracy, and they are extremely happy with what they're seeing in these sort of multi-camera inspections that are inspecting consumer products from multiple sides, looking for different things. All this is solved in minutes, versus sometimes it would take weeks, if not months, to train, iterate over the model, go back and forth. So it makes remote support and bringing up production lines for these customers in various locations around the world incredible. Additional value is once that is done in one location, if they're building the same product in a different location, they, they can just take that model and transport it instantly, and they get instant results. So it's really been a game changer.
Well, as you know, there's always concern about AI and jobs, and how do you see the AI-powered inspection changing the roles and the skills of those on the factory floor, including the engineers that would be analyzing the data?
Yeah, this is always a concern, and I think it's the at least in the space that we provide information, this concern is not founded in reality or in fact. What we actually provide is that a capability where these same people who are doing inspections and really had very boring jobs of just looking at product being manufactured and looking at defects. It was a job that was difficult because of the long hours that they would spend on doing the same thing over and over and over again, which is just looking at an item coming out. We actually offer these people training and take them to a new level of uh, essentially value. So the value creation in the people that learn and they become really indispensable. We're taking just the simple act of finding problems to uh, teaching a person how to use a product that can now uh, find problems, gather data, and an actual story is they're using now this data to go upstream in where manufacturing happens and see, well, what is the defect that is occurring, and how do I take the information that elementary is providing me and use that to better manufacture the product so that I try not to get this defect in the first place? How do I make product with less defects so I get less waste? So they are focusing more on efficiency of the production lines, efficiency of the factory, rather than just being a filter for finding problems.
Sounds like it's even moving from, predictive to prescriptive.
Absolutely.
Yeah.
Absolutely. So we're in fact an interesting story was we were working with one of our customers who introduced us to another one of their vendors, which makes the machines that actually make the product. And we were introduced to this machine builder, and we said, well, we'd like to work with you because we have rich data sets that have been collected over the years that might be of value to you of improving your machine quality so that you can manufacture less defects. And they told us, well, we've already been using your data for the last year from this company to improve our machines. So we're already there. So data as a currency is a cliche, but this was a real use case of where what we wanted to do was already being done for the better part of a year. And it was exciting to see that.
That would be. And looking forward, where is elementary headed? This is a bit of a two-part question. Where is elementary headed, and what advice would you give manufacturers who know they need to modernize but aren't sure where to start?
Yeah, I would say, we want to not just be the inspection company, but we want to be the data platform. And uh, in manufacturing has been late to enter into a world where the factory systems are connected to the cloud, introduced new capability in there. Manufacturers are often scared when they see security vulnerability issues. And coming from the world of cybersecurity, I see that where a large company, their corporate side is well protected with respect to information security and cybersecurity. Their manufacturing world, the protection that they provide is by isolation. And isolation provides them protection from the world of uh, threat actors and other things, but it also keeps them sort of in the dark in terms of modernization. So modernizing, bringing these systems to cloud-connected capabilities, bringing them to the world of software solutions, SaaS solutions, where new features can come out every couple of months, and allowing data to be collected in a way that that data that can then be used to proliferate across their different factory systems to improve that and improve the efficiency across the board. That's what Elementary wants to drive, is that it's not just finding the problem, but how do you create systems that can avoid that problem in the first place and drive a high degree of manufacturing? Because it's not just zero defects that we want to drive, but it's also zero waste. So that together with that, we provide the best efficiency for these factories. And that's where we'd like to take Elementary.
Well, we will leave it there. Thank you, Milind, for joining us on the podcast. I really appreciate your time.
Thank you very much. Thank you for taking the time.